Hello everyone, I am Leia Katingob, and in this video I am going to discuss the 3 out of the biogeochemical cycles that occur in nature. I am going to discuss water cycle, nitrogen cycle, and the carbon cycle. Materials that make up living organisms find their way back to the physical environment and are reused by other living organisms, such as the cyclic process of materials ensure the continuous supply of much-needed materials to sustain life in ecosystems. Ang tawag sa mga pathways na ito ay biogeochemical cycle. First cycle that I'm going to discuss is the water or hydrologic cycle. To explain the cycle first, kailangan natin ng isang body of water just like this small pond. Evaporation from the bodies of water released water vapor into the atmosphere. After that, the process of condensation changes water vapor back into liquid water forming clouds above. Then they return back to the earth in a process called precipitation, which may be in a form of rain, snow, and other forms of precipitation. And when it precipitates or it rains, the water on the ground infiltrates into the soil in a process called infiltration. When excess rain water can no longer sufficiently infiltrate, the soil it flows or run off over the land surface. It may stay stagnant on the land or it may be combined to other bodies of water. After this evaporation will occur again. Hence the water cycle. Aside from these processes, we also have one process which occur among plants. It is transpiration. Transpiration is simply the evaporation of water from the leaves of the plant. It also contributes to the amount of water vapor in the atmosphere. Now let's proceed to the nitrogen cycle. Nitrogen cycle is an element. It is colorless, odorless, and tasteless gas. 78% of our atmosphere is composed of nitrogen. It is also present in ocean, soil, and all organisms including pests and animals. Nitrogen cycle is the process by which the nitrogen is converted into nitrogen compounds through the atmosphere, soil, and organisms. The nitrogen from the atmosphere, soil, dead organic matter, and animal waste are converted into nitrates by the specialized bacteria to make it usable for all living things such as plants and animals. These nitrates will be converted back into nitrogen gas and it will return to the atmosphere wherein the new cycle will start again. The 5 processes of the nitrogen cycle are: Number 1. Nitrogen fixation. Nitrogen fixation in the atmosphere is the process of converting nitrogen gas into nitrates through lightning. Nitrogen fixation in the soil is the process of converting nitrogen gas into ammonia by the bacteria living in the roots of legumes. Number 2. Nitrification. Nitrification is the process of converting ammonia into nitrates by nitrifying bacteria. Number 3. Assimilation. Assimilation is the process by which the nitrogen compounds such as ammonia and nitrates are obtained by plants and animals. Number 4. Ammonification. Ammonification is the process of converting dead organic matter and animal waste into ammonia through the action of bacteria and fungi. And number 5. Denitrification. Denitrification is the process of converting nitrates into nitrogen gas by the denitrifying bacteria. Carbon cycle. Circulations of carbon from atmosphere to biosphere, hydrosphere, lithosphere, and returns back to the atmosphere is known as carbon cycle. From atmosphere, CO2 enters into plants through photosynthesis to synthesize food particles. CO2 enters into territorial organisms when the plants are eaten by them. When these organisms die, it enters into soil. CO2 enters into water as carbonate to perform photosynthesis. In the drugs, it is available as limestone. How CO2 returns to atmosphere? From fossil fuel, from respiration of animals, from burning of wood, a release of smoke from motor vehicles, and industrial extractions of fuel, cement, manufacturing, forestation. If the amount of CO2 increases in the atmosphere, it leads to the disturbance of natural carbon cycle. Release of chlorofluorocarbons (CFCs) from air coolers and refrigerators to lead depletion of ozone layer and global warming. We should always try to maintain the carbon concentration that is 0.03%.